Welcome everyone. Welcome to this day 5 of the online FDP and very good evening. Some of you are just joining. So I just want to say that the course that is there on the group, it's there to help you to score 70% marks in the Atal certificate. Otherwise, if you score less than 70% marks in the assessment, then you will not be able to get the Atal certificate. So in the last batch, some people were there, some faculty members. You are taking so much time to attend the classes. So first of all, thank you so much for taking out the time to upskill yourself. Hats off to you. After a full day teaching, you are joining this class. But I'll request you, and also you don't need to put your name in the chat. If you just join on Zoom, we will match it with the registered email ID on Atal and we'll mark your attendance. So don't worry about that. So what I'm saying is that if you complete the course, it will help you to score that 70% mark. इसको ही रहने दो. अच्छा. So it will help you to score that 70% marks in your assessment. As I was saying, in the previous batch, some people got 69%. So if you have 69% marks, then basically you will not be able to eligible for the Atal certificate. So even 1 mark is very important when it comes to getting your Atal certificate. You are spending so much time. I'm sure you want the Atal certificate, right? One is you attend all the lectures. Second is that course, because the assessment is based on that course. So I'll just request you to also complete the course. Take some time. I'll give you time till Sunday to complete the course and take the assessment. So you have the whole of Saturday and the whole of Sunday to complete the course and take the assessment. I really want that you should all score more than 70%, so that you are eligible for the Atal certificate for which you are taking so much trouble. Hello, Dr. Gopal. I see that you have joined. Good evening, sir.
Very good evening. I'm ready
How are
and
you?
I listened to the speech by Shikha, lecture by Shikha for some time and then come back.
It is Dr. Surya Prakash Gotetti's lecture. I will just request him to join. I think he should be joining any minute. Today it's his first is his lecture. Oh, he doesn't have the meeting link. I'll just send him the meeting link. Okay, one second. अभी नहीं रुको नहीं मैं डिनर के साथ खाऊंगी
Yeah, good evening.
Yes. Good evening, Dr. Gotetti. How are you?
Yeah, good.
Good, good, good.
Good
Uh,
evening, Dr. Gotetti. This is Gopal here.
so
Yeah,
you can come
great,
on the
sir.
camera.
Oh
Gopal, so you
yes,
can
I'll
come
do
on
that.
the
I'll do
camera.
that. I'll do that. Thank you. Um,
Gopal,
yeah.
sir, were you able to have the conversation with Mahindra University regarding
Sent a
the
mail.
futures?
Sent a
Okay,
mail, and quick conversation. Yes, but more details. I think it has to go through the staff meeting and everything. Very
right.
soon.
And
Very soon.
yeah, because I have urged all the faculty members who are present today also that in case if because right now it's a Government of India platform, there are a lot of incentives for students to join this, take the course. If the course is embedded in the curriculum, even the assessment can be free, and we have lot of tie-ups which are going to be available like with for practical hackathons, for internships, and to make available freely tools which are used for by tech companies. So a lot of things are being planned, already are there. Lot of things are being planned, so it will be very very good for the students to actually be enrolled on Future Skills Prime. So that's why
Let's
I'm
see how.
urging.
Yes, I agree. I'll get back to you by third. Third, there is a meeting, faculty meeting. Let me see how it can be. We'll take opinions on that.
Yes, yes, sure, sir.
But it's
So with
good. Thanks. Thanks for the nice pointers.
right. So thank you
Uh,
so much. And I'll now hand it over to Dr. Gotetti for his session. Any queries from the participants? I will take it at 7:30. So right now, I'll just request all of you, please. Thank you so much for joining. Listen to sir, interact and engage with him. Make the maximum use of this time so that you score 70% on AICT assessment, which is on Future Skills Prime portal. Today itself, I had a word with AICT and they were saying that we have to be very clear that 70% faculty has to score, otherwise, there is no certificate. Even if you get 69 marks, 69%, uh, you will not get the Atal certificate. So, all this effort will go waste. So, I'll just request you to listen. Thank you so much.
Yeah,
Sir, over to
thanks.
you.
Yeah, good evening, everyone. Uh, we'll continue from where we stopped last time, right? So let me just give me a minute. I'm sharing my screen. Let me know if you're able to see. Just a minute. Yeah. Is it clear? Is it visible, my screen? Okay. Yeah, let us start. So, in the earlier session, first of all, very good evening to everyone. Let me introduce myself. This is Dr. Gutedi. I have 29 years of combined experience across academics and industry, and I am working as consultant in Tech Mahindra in AI and analytics. So, today's session I will be focusing on certain tools pertaining to artificial intelligence and machine learning. We also look at some of the fundamentals, right? Because predominantly, even your orientation program and the assessments, right, they will be centered around fundamentals across various subject areas that we'll be going through, right? So please pay attention to this. And if you recall, we talked about natural language processing, right? So fundamentally, natural language processing is very attractive because it is a real life use case. Like, for example, classification of a text, classification of movie reviews, you must have seen from on IMDb, right? And where your data can be structured and unstructured. Like, for example, if you look at some of these feedbacks, right, you'll have text messages along with some memes, along with some stars, right? And people also put some video files, audio files, and all that, right? So this data, which comprises of text and a mixture of other formats, is called multimodal data, right? So multimodal data has become very prominent nowadays, and lot of transformer models, right? What we call them, GPT models. What are the GPT models? Generative pre-trained transformer models. So in the earlier session, we talked about neural networks and the computational model of a neural network, where we said that your network comprises of a set of layers, and two layers are common. One is input layer and output layer, right? Output layer will give you the probabilities across the classes if you are talking about classification problem, and you can indeed use this a kind of backbone architectures. These neural networks, you can use them as even backbone architectures to generate and extract higher order features, which you can feed to some other networks, right? So all these possibilities are available. But fundamentally, it is very important for us to understand the significance and importance of these neural networks, right? So we discussed about every activation node, which essentially takes aggregation, a weighted sum of all the previous inputs, and then you have activation attached to that, right? So the fundamental philosophy of these activation nodes is to introduce a nonlinear decision boundary, right? So we also discuss about various set of activation functions, right? So and ultimately, what it indicates is that you have a more complex abstract model where you feed these features to these nodes, and you try to infer certain outputs, right? So that's what we did. Now today it is more of double clicking all that and getting into more details of overall ecosystem of AML discipline, right? And for that, the understanding of neural networks and as an abstraction and various models in the context of natural language processing, computer vision, that plays a very, very important role, right? So let us begin today's session by highlighting some of the important things that we are going to discuss. So first thing is we will give you overall ecosystem of AML discipline, and then we look at artificial intelligence, recent trends, and what's most happening in this. And after that, we'll get into machine learning life cycle and various tools. After that, we look at comparison of the tools. Then we also look at generative AI because generative AI is more prominent. Generative AI tools or generative AI models, various categories, and we look at some examples, some sample questions and stuff like that, right? So uh, to start with, in this discipline, one role has become very, very prominent in recent past, right? That role is prompt engineering. The reason being that people who work in testing domain, people who work in Q&A, quality, right, and maintenance support, such kind of skill set people, it will be easy for them to acquire these prompt engineering skills, some of the generative AI fundamentals to get into AI discipline, right? Now, because it is given that it is given fact that AI is being adopted across the domains, across the verticals, right? So it is a kind of a decentralization of, if you think of any technology which is a kind of decentralized, the technology is and that those tech stacks are artificial intelligence related tech stacks, right? The primary reason for that is if you look at prompt engineering, we said that how do you design the prompts, understanding the response, particularly if when you are dealing with the complex problems where you wanted to give no, no, I have not yet changed the slide. I am still giving you the background. Is it clear? Yeah. So then we talked about importance of these prompt design techniques, including few short prompts and chain of thoughts, etc., etc. Right? They're very fascinating things to learn, right? So as a continuation of that, when you think of uh, a language. Mm. Processing, we also revisit some of the tools pertaining to natural language processing. That is what we call NLT, Natural Language Toolkit. I will show you how to use that, and we'll discuss as it needed. All right. So let us recap what you have actually gone through all these days. Right now, I hope that you are able to see the change of the slide, right? So, so AI is a discipline which focused on creating machines that kind of mimic human intelligence through various traits such as reasoning, learning, perception, and problem solving. That is the higher level of your hierarchy. Next level, you have machine learning, which is a branch of artificial intelligence with focus on uh, learning from data. So when you talk about machine learning, first thing that should come to our mind is that how do we build models that learn from data, right? That means the definition of machine learning, if you see, it is essentially like this, right? So uh, it is basically learning from the data without explicitly being programmed, right? Without explicitly being programmed. So that involves a whole bunch of algorithms, which we'll be discussing today at length. And then after that, we have deep learning, which is against more specialized discipline from the machine learning, and where we talked about neural networks. We talked about how the computation is happening and how complex this computation, because you are moving from one layer to another, and sometimes you call them deep neural networks because the number of layers is quite deep, because you want to extract more and more complex features in the propagation of it, right? If you recall, we talked about two things, right? One is called forward propagation, other one is called backward propagation, right? So in forward propagation of neural networks, we discussed about how the computation happens, right? Because you have set of features and values, and you have some random weights initialized to these network nodes, network edges rather, and then in the forward computation, you compute the final values. But what you have computed, you want to see that how robust these predictions are with respect to real data, right? That means you basically split your data set into training and test set. You test your model performance on the test data. So when you perform that on test data, you actually go back and change the weights, right? That is called back propagation. So the fundamental principle behind this back propagation is the intuition of partial derivatives, that we call it as chain rule of partial derivatives, right? So that gives you an intuition for the model to learn individual weights, or model to get fine-tuned automatically by itself these adjustments of these weights, right? And after that, again, you abstract these deep neural networks into another abstract model called large language model, right? Large language models are the models which are trained on huge corpora and huge data sets, and then weights of these large language models are fine-tuned, and you are essentially using pre-trained large language models to use them for other generative AI applications where you want to generate new content. New content can be something like text, it can be image, it can be music, or it can be code as well, right? Now, recent past, this has become very, very prominent. That is called vibe coding, right? In vibe coding, what you do is you leverage these large language models, take help from them, and use them for refactoring your existing code, or try to add some enhancements to existing code, etc., which essentially saves a lot of time, right? So that's where you see a lot of improvement in the productivity. Now, on subsequently, another emerging area that you must have seen is agentic AI. So, agentic AI is based on agents, right? What is an agent? Can anybody tell what is an agent? Hello? What is an agent? No, no, I'm not asking a synonym of agent. I'm asking technical description and definition of agent. So it's like this. Agent is an entity which or application which interacts with the environment, and it will have some rules to look at, right? By looking at the rules that are given to it and the response from the environment, it will take decisions on its own. These decisions are called autonomous decisions, right? Because the ability of the agent to take decisions on its own by interacting with the environment and learning from its experience and also from the set of domain rules that you are providing for the agent. Can I give an example? For example, if you see, uh, you have a very, very minute agent, like when you log into any website, right? So you see that it will pop up saying that I am, let's say, Asha. So what is your question? Then you type, then it will give menu driven options. Then you select the menu, isn't it? So these agents are somewhat, programmed agents. But in real definition of agent, if you look at, they automatically take decisions through two mechanisms. One is called exploration, and other one is called exploitation, right? So the fundamental model of agentic framework is built on an abstract model of what we call reinforcement learning. Have you heard about reinforcement learning? Hello? Correct, correct. You are right. Very good. Very good, Rukmini Devi. Dr. Rukmini Devi said very nicely. She has put everything in detail. So, for agentic AI, we need to first understand that fundamental computational problem which originates from reinforcement learning. Okay, all right. So as we see here, you have data which is of multiple types, semi-structured or unstructured or structured data, right? So this we deal with models, and we also deal with various complex data types like this, right? Now, if you recall, in traditional application development, right? We always worry about few data types like integer, float, character, string. Now look at the way this whole paradigm got shifted. Now when you say data types, we are talking about structured data and semi-structured data and unstructured data, isn't it? And this is the terminology that we follow even for we follow for all data driven decision systems, right? Data driven decision systems can internally be using AML techniques, agentic models, and things like that, right? So as I said earlier, this is the overall hierarchy. We have AI. Under that, we have machine learning, then deep learning, generative AI, and agentic systems, right? So now, if you look at the way uh, things are changing, right? Now, you get into a conversation of project discussions where you say that what is the FTE, that means full-time employee, how many people required for this project, right? Now, with going back next couple of years or very closely, you will see that you will be getting into conversation with the customers in terms of how many people we are going to use in this project. We'll say that okay, there are 5 people through 2 developers, one tester, one lead, and 3 agents. And you also give them names also, right? Based on the roles that they perform. So everything is going to make a significant transformation, right? Because we are talking about certain applications which are abstracted as agent, working like the way we work with the way we interact with our colleagues. So that's the way these things are becoming so prominent, agentic AI. Now, if you look at a big picture, essentially, you can choose what this the slide says is that it's a kind of a roadmap for you. You can pick up any of these areas. We don't one has to, rather one need not be an expert in all the domains. These are the various domains we can do. ML areas, you can get into ML area, you can get into NLP, speech, so on and so forth. Right? So computer vision is particularly becoming prominent in healthcare domain, especially medical diagnostics related things. And NLP is becoming more prominent for language models, right? And most importantly, conversation uh, and translation from one language to another, text to speech, speech to text, things like that. Now, let us start with machine learning algorithms. So, machine learning, when you think of, predominantly this, we may not have to look at this actually. This is a special case. So, we have supervised and unsupervised learning, where in supervised learning, we have two types of problems. Uh, One is classification, and other one is a kind of a regression problem, right? Yeah. So, and on the other hand, in unsupervised learning, you have a clustering, associations, and a feature exploration. Then within the clustering, you can think of partition-based clustering, hierarchy-based clustering, and density-based clustering, right? We'll discuss in detail. So, so let me just explain these things on whiteboard. Hope you are able to see the board, right? Can you confirm? Yeah. No, I'm saying blackboard. Can you see? Hello? No? Give me a minute. I'm resharing. Can you see now?
It's coming up,
Yeah,
but not.
good.
Yeah, your whiteboard. It's your board. It's a blackboard.
Yeah, yeah, yeah,
Yeah, we can see it.
yeah, yeah. So we have set up use cases, right? Suppose you think of use cases. One is uh, you want to understand the risk of a disease, right? Something like, you know, diabetes or whatever, right? So this comes under classification problem, right? Now, problem with current research, right? I mean, I'm talking about some of the papers, which you see normally in machine learning. They predominantly focus on improving the accuracy of the model. Like for example, I have features like this. I have D features and I have a label Y. Now we talk about classification setup first. So in classification setup, what happens is you evaluate the model based on uh, based on you know what we call classification report. What this classification report, right? It is actually, it comes from the contingency table called confusion matrix. So you have actual labels. Actual labels, it can be two labels. We have yes and no. Yes means, you know, the label is yes, label is no, like that, right? We are talking about label data. And you also have predicted. So in the case of predicted, what happens is predicted yes and predicted no. So if you look at this region, actual class is yes, predicted is also yes, this is called a true positive. And actual class label is negative, predict also negative, this is called true negative. Actual class is yes, but predicted as class no, which means it is called incorrectly predicted as negative. Similarly, incorrectly predicted as positive. So from this, you define certain metric. So these metrics are called accuracy. Accuracy is nothing but true positive plus true negative divided by all, sum of all, right? Sum of all four. Now another one is called precision. In precision, it is true positive divided by P predicted. Out of all positive predictions, how many of them are actually positive? There is something called recall, which is given by true positive divided by P actual. That means how many out of P actuals, how many you could recollect, things like that. So to balance these two, you have what we call is F1 score, which is given by 2 times, if you denote this as P, you denote this as R, precision into recall by precision plus recall. Now, there is something else also, what we call as ROC curve, right? It is true positive rate and a false positive rate plot. I am not going into that detail, but most important thing is in healthcare applications, out of all these parameters, recall is most important actually. Why recall is more important in healthcare? Can anyone tell me? Critical parameter, that means evaluation parameter in medical, because the recall is given by true positive by P actual. Right? So out of all positive cases, how many of them actually your model is able to unearth then from the training, right? Or predict from the make the predictions appropriately, correctly. Now the problem is, suppose if your false negative rate is high, what is the problem? The false negative rate is high, the model able to model in fact is incorrectly predicting as negative. That means even the person has a disease, the model is predicting that the person is perfectly fine. then the problem is this, the effect will be catastrophic, right? Why? Because of the wrong diagnosis where the model is saying that the person is perfectly fine and the person will not go to further tests, he will not go to other medical examinations, and hence he will get into a risk zone. That's why we should be very, very clear in terms of what our models are predicting, how they're predicting, what are the risk markers. If you look at the literature, right, some of the basic papers, right, predominantly people are focusing more on publishing papers using some open data sets and improving the accuracy, improving precision, and comparing that with other published literature and all that. Why I'm bringing this point is because all of you from academic fraternity, I want to urge you that you should not make such mistakes, because good quality research, if you think of, uh, you know, it should be centered around design of new algorithms and adapting different techniques, things like that. Okay, not just running these machine learning or deep learning models and doing some changes here and there, right? So risk analytics is very, very important area. Suppose you want to identify the risk, like for example, elevated risk of having a disease and moderate risk of getting the disease. Such kind of risk analytics plays very important role. I will show you one use case which actually I have developed for risk modeling. Okay, so that you will get a better understanding of how the risk modeling is being done. Right. All right. Now, this is all about classification task. In the case of regression task, you are predicting y. Your y prediction is a real number, that is floating point value. Example, suppose you want to do stock price prediction. Similarly, you wanted to do something like, you know, house price prediction, and you wanted to estimate some parameter value, etc., etc. Right? So there your measure will be something called mean absolute error. That is, you are able to understand clearly, right? Which is given by y predicted minus y actual for each instance, summation over all that by n, right? So what is this I here? Because I have a data set x1, x2, xd, and you have y actual. Now you split this data into train data and test data. So on the test data, you are measuring this, right? So what happens is that in the mean absolute error is especially helpful when you want to know the magnitude of deviation from its actual value. There is something called root mean square error. Which is given by y predicted for each example, y actual of each example, you take square, and you take this square root, right? So these are the sum of the measures, and you also have r square and adjusted r square. So these are the measure of variance in predictions. Okay, these are the measures. Now let me go to the other things. Then we said that unsupervised learning, right? One of them is clustering. So in clustering, you might think of data which is spherically distributed. So that's where your k-means clustering is very appropriate. So what you essentially do is that if you are doing some customer segmentation into multiple groups, this one cluster C1, right? This is another cluster C2 with centered around a specific fixed point. This is called centroid. Okay. So now if you have C3, another cluster like this, now you measure two distances. One is in within the cluster distance of each data point. If you take data point P, what is the distance of P from this internal center, right? So your measure will be uh, a fraction of interdistance measure over intra-distance measure. Means how far the clusters are separated versus how compact my data points within the cluster. Okay. So there are various measures that you have like silhouette distance and all that, but this is basically what it is. But in real life, real data, not necessarily all data use cases, data sets of the use cases may follow this kind of a spherical distribution. In that case, you go for either what you call density based clustering or hierarchical clustering, because this particular technique of k-means clustering is susceptible to outliers, because when you have abnormal values means the values which are too low or too high, then these algorithms find it difficult to deal with such things, right? And another thing in the case of clustering you have is hierarchical clustering, right? Hierarchical clustering is also denoted with what we call some dendrogram, right? In hierarchical clustering, you have one cluster C, within that you have another cluster C2, within that you have cluster C3, like that. That way we have, AI discipline, right? It is a good example for hierarchical clustering. So after clustering, we have a few other techniques like association analysis. It is also called association rule mining. What is this association rule mining? Suppose you visit a grocery store, right? You have things like you have certain products. You look at transactions. You have set of transactions, and you want to develop some rules. Suppose somebody purchased milk and bread, and you want to propose a rule. Let's say jam, right? Similarly, you have something like you have a detergent and detergent liquid, for example, right? And you have what we call perfume. And people who purchase detergent liquid and perfume assume that they also, right? They also purchase, let us say, something like for perfume or room freshener, let us say. So like that, if you want to see the trend, now interesting thing here is if you look at these individual items, right, whether it is milk or bread, etc., the attributes are completely different, right? You can't just extract them as a features and try to do some supervised or some other technique. Here, they are completely different items, but these items are closely associated with common usage, right? So this is an example of association rule mining. So when it comes to association rule mining, what are the measures that we have? We have things like support and confidence. Are you following? Hello? Let me see. Ah. Now support means suppose you have a rule, something like A arrow B. Now support means support of this rule is given by number of entries where A and B are present divided by size of the data set. Right? Now, there's something called confidence of the rule A arrow B, which is given by number of entries. We have both, out of which how many of them are from A, or number of occurrences in the data set of A. Right? There is something else called lift. Lift is again, A intersection B divided by N of A into N of B, right? So lift is another measure. So these are the common measures. So every rule that you develop, right? Any rule that you develop, it has LHS, set of items, and RHS. Now associated with this rule, you put support and confidence, both for that rule. Okay, this is about association rule mining. And you also have something called collaborative filtering. This is also unsupervised technique. What is collaborative filtering? There are two types of algorithms that you can see here. One is a kind of special case of is the recommendation systems, right? One is item-based recommender. Recommender. So normally you encounter these use cases for online shopping, right? Suppose if you have something like Flipkart or Amazon, you will get some alerts where you get a message saying that people who purchase these they also purchased another product, right? Are the items that might be interesting to you. That means item based proximity measure that we are doing. And similarly, there are these are the other people who actually purchased this item, right? Things like that. So that is about collaborative filtering. Now, on other hand, we talked about reinforcement learning, right? Reinforcement learning, you need to conceptualize as two things. One is agent, other is environment. So agent will interact with the environment, and because of that it will take an action. So action might be awarding positive reward or negative reward, right? But these kind of problems are more suitable for autonomous decision systems, right? So let us say you have an agent who wants to play chess, right? Not chess, what is a tic-tac-toe or whatever. Now suppose agent put this. Now some other person will put some other person. Oh, and after that again agent has to play. Assume that agent has put X here. Now assume that from here to here, here to here, from here to, let us suppose the other fellow who is actually playing is not able to see the moves of this fellow. Let's say he puts here. Then subsequently, what agent does is you have X, you put X here. Now you won the game, right? Then you get positive reward, let's say some plus 10, right? But till that point, you are not getting any reward, isn't it? Similarly, you can think of agents, something like you want to develop a robot to collect various uh, waste materials in a restaurant, right? Like for example, cool drink cans. So, so agent should take a step, one step at a time, and you measure the performance of the agent based on number of cans, empty cans it collected, right? So you define a goal like that, and essentially you split that into certain rewards, right? So this is about reinforcement learning. So it is actually learning from mistakes. That means when it's getting penalty instead of reward, it will look back and try to correct itself. So this is about reinforcement learning. Let me go back to the slide. I hope you got some big picture of this, right? So this slide means that now let us understand these disciplines, right? When you look at uh, something like AI, ML, data science ecosystem, we talked about AI already. Data science is essentially wanted to generate insights from the data with the help of these models, right? So, and it can, all these disciplines are must encompass through set of broad areas: mathematics, domain, various models and algorithms, data visualization and storytelling, right? And to some proportion, each role that you figure out, whether it is ML engineer or data engineer, with some thing, what happens is that you will be uh, you will be using a small uh, portion of each of these. Now, how does the ML life cycle look like, right? So, whether it is experiment that you would have data science experiment or machine learning comes into model development. So, first you need to define a research goal, and then you try to prepare your charter. Then you can extract the data. So, data can come from your internal sources, or data even come from various external sources, right? So internal sources is easy, but when the data is coming from external sources, you don't have any control on the format of the data and structure of the data, right? One has to do a lot of pre-processing activities, right? Then you prepare the data. How do you prepare the data? You kind of give data cleaning actions, you take data cleaning tasks, and you apply transformations and do the data aggregations, right? What are the data transformations? So when you have a data set with a set of features, sometimes you might be having lot of features compared to number of records. So in that case, you will be using some unsupervised learning techniques for reducing number of features. That these are called dimensionality reduction algorithms. You will use things like principal component analysis, right? Or you will be using some ensemble methods to that gives you feature importance with respect to the classification setup, right? You will be using these techniques. So after that, you will be performing exploratory data analysis prior to model building. Then once uh, model is developed, you will be evaluating the model using some of the parameters that I said, right? Then you actually deploy the model for the consumption for the outside. What are the tools that we have, right? For this, you can think of NumPy and Pandas libraries for the data cleansing, Matplotlib library, and Power BI also you can use for data visualization. And then you will have a scikit-learn library which will support all the machine learning libraries actually. Then for natural language processing, you'll be leveraging on NLTK framework. And of course, social network analysis, etc. There is something like networks library. Now, computing is very, very important concept, right? When you are developing these models. So in the perspective of computation, what are the computational models we have? We have CPU based computation and GPU based computation. Um, right? So we can differentiate them in the aspect of three, four items. One is architecture. The architecture wise, CPU architecture is simpler compared to GPU architecture because GPU is collection of small cores which can run operations in parallel. Now, training speed for CPU it is slower because you have only small number of cores. For GPUs it is high because you will be using a lot of cores and it will be able to cater to deep neural networks, especially in medical imaging and security related applications, right? Then cost wise, obviously since you are utilizing less number of cores, CPU is cheaper than GPU. And in the scenarios or use cases where CPU is better, when you have lightweight inference is okay, then you try to take a sample of data and run with a single machine. But if you want to deal with more accurate insights, if you want to get, you want to deal with large volume of data sets, then probably we'll be using GPUs either for accessing pre-trained models or large language models. There are some other examples, right? RTX and all. So NVIDIA has become more prominent in recent past because of the infrastructure facilities and computing infrastructure facility that is offering. And federated learning is something, which is becoming very, very popular nowadays. How do you perform these computations on in a distributed manner without compromising on explainability and things like that. See, in machine learning also you have set of models which are good in explainability, like decision tree algorithm, right? So there are certain models which are robust, but they may not be good at explaining something like support vector machines, right? So decision tree algorithm and support vector machine algorithm, these algorithms can be used both for classification problem as well as regression problem, right? So I am not getting into details of individual algorithms, etc., because it's a deep dive session. I just wanted to give important pointers so that you can figure it out subsequently, right? Now we have various frameworks which are listed over here, and you can see a single snapshot of all these frameworks, right? So one is PyTorch, which is a deep learning framework, which can be useful for research and rapid prototyping. And scikit-learn, as we discussed, it is a most popular framework for traditional machine learning experiments. Then JAX is more high performance ML library. It has become very prominent nowadays, actually. And so is the other Onyx and all that, right? So if you want to compare of deployment tools, there are similarly a lot of deployment tools also are available. You can think of deployment tools something like TorchServe or MLflow. MLflow is more popular. How do you do the seamless deployment? Because the purpose of developing these models, fine-tuning the models, and finalizing the models, essentially, should lead to something more tangible, right? So these model you store it as some pickle file or something like that, and try to use it in the deployment environment. Once you deploy this uh, ML or this model, then subsequently you can use it on day-to-day basis, right? Now, MLOps has become more prominent as well. So these are the MLOps tools. One is MLflow and Kubeflow, Kubeflow and Airflow, right? So these are the some of the uh, specific aspects, including strengths of each of these ops tools and what kind of features it has. For example, Airflow, it is based on some directed acyclic graph kind of thing, and it is very good at in terms of ETL orchestration, right? Which is little complex. So on the broader level, when you divide these models can be divided into two categories. One is discriminative model, other one is generative model, right? So discriminative model comes under either classification problem or regression problem. What is discrimination model? You always express the model in terms of y is equal to f of x. So some cases y can be a categorical discrete number, or sometimes it can be a floating point number. So that's how you switch between classification problem and regression problem respectively, right? So on the other hand, generative models, they learn from existing content. They create something entirely new, creation of new text, new image, uh, right? New video, new audio, etc. Right? Now let us understand the large language models. What are the large language models? Large language models are general purpose models which can be pre-trained and which can be fine-tuned for specific purpose. So these are some of the characteristics of large language models. Number one, they are trained on vast data sets or massive data sets, and because internally they will be using these neural networks, right? So that's where this becomes more uh, prominent. Now, of course, they are based on neural networks, and they try to learn statistical relationships. They learn probabilities, right? And then, for example, predicting the next word in a sequence. So essentially, sequence modeling is a very, very important thing. As I said earlier, because you have a couple of use cases, something like you want to give complete context to the model, and you want the model to give you some inference, right? Similarly, you want to you give a word and you want to get some context around it. So both are possible, right? Now let us understand generative AI architecture, right? Typically, a generative model follows something like that. You have input features, something like the prompts that you give or text that you type. Everything is getting converted into a vector, right? Because models work based on the computations, which can be done on some numbers, right? So we have random input vector, which will be fed to a generative model, something like this. From generative model, it will generate new instances. On the other hand, you will use a discriminative model to test this generated example, whether it is close to actual or not. So based on that, you will be computing misclassification rate and use that feedback so that our generative model develop uh, quality instances. Right? Any question so far? Hello? Okay. Now, generative models again further classified into multiple models within the hierarchy actually. First, we have density-based models and approximation models. In case of density-based models, we have explicit density models and implicit density models. The examples for implicit density models can be like generative adversarial networks or GANs, or diffusion models like DALI or Midjourney, right? On the explicit density models, we have GPT models like generative pre-trained transformer model and GLOW also, which is basically another flow-based model. So now let us understand some use case. Like I told you, right? It is not just a prediction kind of a thing, but you also wanted to know about how do you do the risk modeling, right? Some data set example I have taken here. It is some Alzheimer's disease data set which is available open source data set, assuming that there are 11 features. So uh, basic background is that if you see here, what are the factors of influence on Alzheimer's disease, right? You want to study. So typically, if you look at machine learning tasks, people are interested in predictions, right? But what I'm trying to show you is how do you do the risk modeling instead of just predicting whether it is Alzheimer's disease person or not, right? Some these all correlation analysis. And what we are seeing here is a kind of uh, features, how they are connected with each other. ASF is one feature, ETV is another feature, how they are connected with each other. So there is a relationship between the features. So you want to remove those features because the heat map is a correlation heat map that can only consider linear relationship. But here, if you just plot these two features one with another, we have a nonlinear relationship. So you can actually model this using some linear regression model, which you see as a red line. The reason why we are not using a polynomial regression model is that our intent is not to have a nearly perfect fit of these features, because the idea is that I want to construct a new feature by removing one feature, right? Similarly, I want to understand the strength of each of them, right? For example, ASF is negative 0.64. That means if I change one unit of if I want to see one unit change in ASF, essentially that is like something like 64% of this ETIV, right? So these are the inferences that you get. Then I wanted to define some kind of a risk mapper, whether it is a low risk, moderate risk, or high risk. Then these are the various algorithms where I got kind of performance of the model. But interesting thing, if you see the literature, people have published the papers with like accuracy of 96% and all that. But what actually missing is the risk modeling in that. And similarly, there is something called CDR as a feature. CDR is something like uh, dementia rating, which is again kind of a class problem, right? So it doesn't make sense just by using these features and predicting something, because CDR anyway is a direct implication of your Y label. So we are using different techniques, and now you see how the accuracy is improved and classification is done, right? So essentially, this is the kind of risk modeling we can take up as a problem statement and try to come up with this, right? Some of these things. And another thing I want to show you is how do you develop, you know, experiments for the natural language processing. Give me a minute. So suppose if you want to do some NLTK example, you can take this. Let me just share the screen. So this is an example of how do we work with natural language toolkit, NLTK. You can just install NLTK and download. What I want to do is how do I run the NLP tasks, right? You take simple sentence. NLP is interesting subject. So you are importing word tokenize and sentence tokenize. So basically, what is the role of tokenizer here? It will split a given text into individual words, right? And but these words may not, there may be repetitiveness of these words, right? So that's where we will do stemming. Stemming in the sense that there are many stemming algorithms available. For example, in this case, we are looking at something like Porter stemmer, right? Porter stemmer is one algorithm. There are many such stemmers are there. You can just figure it out. Then whether it is sell or selling, sold to, all will carry same simple word called sell. So that's how you can actually remove the words which are of close proximity, right? So then we do limmatization. Limmatization also, again, we have a lot of architecture related algorithms. I mean, a lot of algorithms that we have, which can be used across different type of architecture related problems. So here, uh, what is limitizer? What does a limitizer does? Limitizer will construct, will convert the given word into its dictionary form called lemma, right? To give an example, you can think of send, sending, right? In sending, if you remove ing, it is send, right? So send is a dictionary word. So after that, you will do part of speech tagging. What is part of speech tagging? You will see here. Java is good programming language. Then you construct this. Now let me run this. You will get the tags here. I'm running all the cells right from the beginning. You can see that here. So when I install NLTK library and then I'm downloading this. See how it is getting all the binaries that are required. So then limitation grouping similar words. So place, played, play, playing, all will give the same word play. POS tagging, that is parts of speech tagging. It is a noun, adjective, right? Like that. It will give you those things. Now another important task is named entity recognition, right? Named entity recognition refers to things like person, place, right? Uh, you know, is it a place, is it a person, and so on and so forth. For example, you have this, you're downloading some strategy for this. Then you are taking a text here. I am doing POS tagging. First, I need to tokenize. After that, apply POS tags for the tokens, and then you get the entities, named entity recognition, right? Named entity recognition is something which will give you here Donald noun Trump is like that. Now sometimes you want to print as a tree also, that is also possible. Now you want to develop a chartboard, ready-made chartboard, right? So for example, if you say nltk.chart.chartboard, you can simply which chartboard you would like to say. Suppose I want to prefer, let us say, uh, 5, right? Now give me examples for LLMs. I'm not sure whether it works or not, but I'm now you see the option that is giving. Have you ever considered that you might be a selfish person? Why it is so? Why it is so? Because it depends upon what corpora it got trained, right? Now, similarly, so you can do even other things also. Similarly, I will show you one more thing. Let me just so this again another example. How do you construct token? Each word you are constructing. Then you are taking each word into POS tagging. Then these are the tokens that you got. These are the POS tags that I have. Then you can construct a rules. Sometimes what happens is, especially you want to develop a custom what in let us say in healthcare, right? So you wanted to give certain rules how it should respond. So, but again, there is a limitation called context-free grammars, right? So you can prescribe a context-free grammar, something like this, with set of symbols and terminals. And given the context-free grammar, now you have set of tokens from the sentence, and you want to parse this sentence using that context-free grammar. So this is the parsing, right? So one of the important thing some of you from science background might be knowing, you constructing the grammar is a very difficult task, right? Because particularly for the natural languages, because most often you deal with ambiguity, right? So when your grammar is ambiguous, then you will be having more than one parse tree for the same sentence, right? That is one of the thumb rules, right? Whether the grammar is ambiguous or not. If you are generating more than one parse tree for a given sentence, then probably you can say it, the grammar is ambiguous, right? This is how you can construct parse trees and stuff like that. So people who are teaching courses like compiler design, right? Automata theory and compiler design, that's a very good course actually. If you have that kind of background, it is easy for you to get into the domains such as natural language processing, right? So these are core computer science. These are actually stemmed from core computer science uh, stuff. Now, what I will do is I will stop this and I will share some sample questions because I'm sure all of you are interested in what kind of questions you will be asked in the exam, right? So probably some sample things I can show you. Let me share my screen. Is my screen visible? Can you see my screen slide? So let us say that some prompt engineering we have. We did this right earlier. We talked about these topics. Now, what is persona pattern? Do you remember? What is persona pattern? So persona means it can be a role or it can be a person, right? So you are giving more custom prompts, right? So which option is correct from here for this? I am seeing your chat box. Type some option, right? Oh, correct. Now, similarly, suppose look at this. What is the option correct in this? Which option is correct? B. Very good. So, what is the advantage of persona patterns? Which option is correct in this? Are you able to see my screen? Tell me which option is appropriate here in this example. No, no. The option is C because the persona patterns will guide the model's tone, expectation, perspective, right? Because the way doctor looks at patient is a different perspective, right? So personas are very, very important in the context of tone, expertise, and perspective. Now look at this question. What will be the right option? A teacher designing prompts for educational chatbot. Which techniques best applies? So what is the goal here? Patient tutor, right? That means you are talking about persona here. So you set up a persona with role play instructions. That will be the right option. Now we have this bias and variance problem, right? What is a why does a bias occurs in these models? Is it because of overfitting or human bias embedded in training data, use of deep learning model, random installation of weights? What is the reason? There could be some bias which might trigger due to human factors, right? Because overfitting is an outcome actually, nothing to do with bias. Now, what is the purpose of what is the fairness in these large language models or generative AI or agentic AI the model development? What does it mean? Fairness means yes. See, what it should provide equitable treatment across different groups of people. Now, a leading age system approves more loans for men than women. What it is called more precisely? Hello? No, it is not. Yeah, bias. It is called gender bias, right? Yeah. So we can think of such things. I will actually share these things with you. Okay. So I will stop here. Thanks for your time. I hope the session is informative.
Thank
Thank
you
you.
so much.
Hope I
Thank you so
am
much.
on time, right?
Yes, yes, absolutely on time.
Yeah.
And thank you so much for that session and
Thanks.
also taking the quiz questions. I think that will help all the faculty members to mm, as I was saying that they have to score 70%, otherwise all this effort will be waste. They'll not be getting Atal certificate.
Another important thing is they need to go through the courses whatever they got allotted to, right? Because
Yes,
that
yes,
we may not be able to cover entire content in these sessions. So going through that will certainly help them.
yes,
Uh,
exactly, exactly. So
okay.
I'll just advise everyone that it is a course with 33 modules, but please go through that course, the DAF STEM course,
It
before
will
you
not
take the
take
DAF.
that much time actually. Every day, 30 minutes. If they spend 2 3 days, they will be able to finish.
Yes, 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 yes. We will do that. And if you just give some time every day, you will be able to cover the whole course, finish
Hmm.
the course. And also, if you finish the course, you will be getting a completion certificate from NASCOM, like a participation certificate from NASCOM. And then when you take the assessment, you will be, in case if you score 70%, you will be getting a certificate from Atal. So I have already shared in the group the step-by-step guide to completing the course, logging in, completing the course, and taking the assessment. So please see that, and all the best for that. And if there's anything, if there's
Okay, thank
any
you.
issues, yeah, thank you so much. And if there's any issue, you can, I'll put it in the chat. You can take a screenshot and write to support at Future Skills Prime. Yeah, yeah, marks will not be visible right now, Aarti ji. Right now on Future Skills Prime, 50% and above is a pass mark. We will be taking out the combined, we are giving you time till Sunday to for all of you to take the test. So by Monday or Tuesday, we will go to the assessment agency, get the marks, actual marks, and upload on Atal. There, if it is 70% and above, you will get your Atal certificate. If you're showing a pass, it means you have got 50% and above. I don't know what's the percentage that we have to get from agency. So if there's any other issue, please you can write to support at futureskillsprime.in and copy me. And with that, I will pause here and hand it over to Dr. Gopal for his session. I'll request you to please engage and interact and listen very carefully. It's very important that you listen carefully so that you can get the required marks for Atal assessment. Thank you.
Good
Over to
evening.
you.
Yeah, good evening and thank you very much. Definitely, Kamna has been in touch with me and updating me on very many things like what she has been speaking. Please do go through those 33 modules. It is very important. Excellent content has been put together and it will be very useful. Though this talk for 90 minutes on a very, very important subject, I should say, responsible AI is a bird's eye view of what exactly happens. I am drawing some slides content from the NASCOM portals. NASCOM has a responsible AI hub and it has a toolkit. Now let's see what is it that we are having on hand today. It's a bird's eye view, a quick overview of what we should be doing. And let me share the screen. Is the screen visible?
Yes, it is visible, sir.
That's nice. It's my duty, and all of us would definitely love to think of the Mahatma, homage to the Mahatma, Publications Division. It's a cover page of a book published, Ministry of Information Broadcasting, Government of India. It's also called Martyrs Day, Shahid Divas. Shahid in Arabic is rooted in the notion of witnessing and is oftentimes translated to martyr or witness, referring to an individual who dies for their faith, a noble cause, or in defense of justice.
So you can project your screen to go full screen. You can do that.
I can. So it is something which
Like
we need to keep in mind. Let me see how it is
close the
done.
background. Yeah, you can just close the format background.
Uh-huh. Now what? It's coming?
Yes, 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 yes.
Very good.
Perfect.
Did
Perfect.
it. So Shahid in Arabic is rooted in the notion of witnessing and is oftentimes translated to martyr or witness, referring to an individual who dies for their faith, a noble cause, or in defense of justice. Very nice, and we have to salute the father of the nation who spun the fibers to weave clothing to cover the nation for centuries to come. It's regarded as Martyrs' Day on his name. Responsible AI and its applications, 30th January 2026. This is my affiliation. What is very important to understand is the idea of responsible stems from the human first. This is what is my first submission. Anything that you want to do around the idea of responsibility should keep in mind blaming technology is an irrational search for scapegoats. At no point in time we can blame technology. And as we progress, we will understand why it's becoming increasingly important to go hand in hand with the machine. The human has to go hand in hand with the machine. Responsibility is very carefully defined, a duty to deal with something so that it's your fault if something goes wrong. Please understand the term duty. All along, when we were trying to evolve a course called Professional Ethics, which was made compulsory for all undergrad students across all engineering branches, way back in 2001, 2003, Dr. Balagurusamy was the vice chancellor at that time of Anna University. We had a full unit dedicated to bring in the idea of responsibility. And along with responsibility, roles and rights will have to be defined. The essence of that unit was that the duties are reflected as roles and responsibility. So NASSCOM has been championing this idea of job roles. I've been associated with that idea for some time. But then it is duty which manifests as responsibilities, roles, and rights. You cannot escape the responsibility of tomorrow by evading it today. That's a nice statement made by Abraham Lincoln, the 16th President of the United States. What is the quintessence of this exercise? Why are we talking responsibilities, roles, and rights? 3 R's in succession. It's to build trust. How do we build trust? We have to learn from failure. I'll bring back this term learning later in the presentation, later in the discussion. Again, you can interrupt at any time, and I may not be able to monitor the chat because I went through for the full screen. Empowering others, ethical behavior, resolving conflicts, personal growth, problem solving, most of it is what a human endeavor is always about. We normally want to do that. There's nothing so outlandish or something that happened only 3 years back or only after AI has come. We want to do it. We want to learn from failures. We want to empower others. We want to have an ethical behavior, resolve conflicts, everything we do normally. But what is the concern here? The concern is responsibility is often considered synonymous with decision making. That's the point that we are making. Therefore, we brought in the idea of roles and rights. Responsibility is often considered synonymous with decision making because taking responsibility means owning the outcomes, both positive and negative, that result from a choice. There are hard choices. There are difficult choices. There are so many uncertainties which will be punctuating my lecture as we progress. There definitely are these considerations in any given workplace. All of us want to do the same. That's build trust, as I said in the previous slide. There's no difference about our goals. The one who decides pays is a common principle. If an individual has the power to make a decision, they must also bear the downside of the risks associated with that decision. So every organization likes to draw a borderline between what should be done as an individual decision making, what should be done as a group decision making. Well, India in government definitely likes to slant more towards group decision making. But whatever you say, the idea of responsibility is often considered synonymous with decision making, and the principle one who decides pays. You can't escape these two. And therefore, what is the onus on a given individual at any given point in time is a mind-boggling range of technology which has simply been overwhelming for various reasons. Let's not talk about why it is overwhelming, but we'll figure out what it is to do. Responsibility is therefore based on trying to arrive at a common ground, a golden mean between individual and group decision making. Decisions are made at various levels. Some are strategic, some are tactical, some are operational. Depends on where the given organization is positioning it. Please understand that when I am talking about responsible AI, as the sequence of the terms goes, the responsibility first people. Then we will talk about others. We have an agreement in principle. The question is, do we all have the same principles? That's a big question in the entire focus on how to make the responsibility synonymous with the fellow who decides, and the fellow who decides pays for all the exercises, including owning up the outcomes. Herbert Simon, 1978 Nobel Prize in Economic Sciences, revolutionized decision making theory by arguing that administration is synonymous with decision making. It's not individual, it's not group. A notion, an abstract idea called administration is synonymous with decision making happened. That's because of Herbert Simon. Bounded rationality. Simon proposed that humans are not entirely rational due to limited information, time, and cognitive capacity. Therefore, individuals cannot maximize outcomes, but instead satisfies, that is, satisfied and it suffices. Choosing the first option that meets the minimum criteria. We are all oriented towards doing our task with due diligence, trying to build ourselves, trying to build trust, all the nice things which we do normally, but then due to limited information, limited time, and limited cognitive capacity, we are all likely, most likely, to stop at minimum satisfaction. Just finish the bare minimal average mark vanda podum is what we have been looking up to. As Kamna was telling, the minimum mark is 70%. You have to score 70%. Inch towards 70%, fine, we have done the task. Who will go up to 100? That's a question mark. It's bounded. We are doing a rational choice. Yes, with all these constraints, limited information, limited time, limited cognitive capacity, yes, it is what we are doing, but we are easily satisfied and the minimum requirement is not so high. Simon's three activities: intelligent gathering, design, and choice. But Simon noted that decisions involve a factual element. Some aspects are verifiable information, and a value element. Some aspects are ethical and subjective judgment. He argued that administration should focus on objective, factual analysis to enhance efficiency. Therefore, from where to where, all of us are having the same goal. Every organization wants to build trust. Every individual wants to build trust. Every group wants to build trust. Through what? Through demonstrable learnings from failure, through empowering others, through ethical behavior, resolving conflicts, personal growth, and problem solving. This is necessary at all levels: individual, group, organization, administration, whatever it is. So Herbert Simon's theory was so nice that we have gotten into understanding that there will be choices. The choices impact both factual and value. And administration is the overall authority on factual analysis to enhance efficiency. The value systems will go towards the individual, to the group, and that will percolate it to the top man, that's the decision maker. This is Herbert Simon. He introduced a fantastic terminology, not now, before he won his Nobel, programmed versus non-programmed decisions. This was a great contribution on which we are building the idea of responsible AI. Programmed decisions, routine, repetitive, structured, follow rules, low risk. Non-programmed, unique, unstructured, and complex decisions. Fast, efficient, consistent, or programmed decisions. Inflexible, discourages. So now the point is the blurring distinction between what was so clearly programmed decisions and non-programmed decisions. Today, most of the non-programmed decisions are also getting amenable into programming because of advanced technologies like AI, as we will see later. Unique, unstructured, and complex decisions are also now getting into the programmable zone. The distinction is blurred. High risk with major consequences, enables innovation, tackles unique challenges, but the understanding is that the dichotomy is now no more so clear. They are blurred. The dichotomy is blurred. And this is a nice way in which Herbert Simon has projected. My thanks to Professor C.R. Muthukrishnan and late Professor V. Rajaraman, from both of whom I have been learning. One of the very earliest programmable way, systematic, verifiable, validatable way was presented by both of them. Professor C.R. Muthukrishnan was a PhD student at that time, and Professor Rajaraman was his supervisor. I worked with both of them. Professor C.R. Muthukrishnan went on to become the former director of IIT Madras. It's in 1970 that this paper was published. Very well acknowledged, well referred paper, just over 2 pages, but they gave 2 methods by which systematically an algorithm can happen in a manner where a computer can be seen to make it almost like a formula. The decision will have a backing of a computational model, which gives a very good outcome, very good research result. It will have a basis of a computational model. Decision-making authority must be distributed downwards. Responsibility tends to travel upwards. The top man. Always the impact of complexity is we would want more and more people to come into the exercise. It will go downwards. Whereas responsibility keeps on traveling up. Because the top man will be involved, there will be subjectivities. The complexity keeps many things blurred. Many things may not be factual, but then there is an ethical component. There are so many other things, subjective components. Decision making is often more collective than we assume, while responsibility is more individual. We have to strike a balance in all these things. Well, as we keep talking about the hierarchy of corporate responsibilities and the levels of corporate decision making are like this. The corporate responsibilities will keep on pushing upwards, almost to making philanthropy as the best method for socially responsive ideas. However, we are all right on corporate responsibility and we manage well with the top management on social responsibility. Over the past few decades, the corporate social responsibility has stabilized, gave lot of foundational ideas, but we should go one more level up now. AI is pushing all this to one more level up. What we must do is obvious: profitability, comply, and commitment to rules and procedures, laws. Social obligation is one. Social responsibility. We have come 2 levels up on corporate responsibilities: verifiable, provable CSR, corporate social responsibility. It is involving top management. It blends well. What AI is doing is almost pushing one more level up: social responsiveness. What is non-accountable so easily is philanthropy. So we need to have more stakeholder kind of an approach, multi-stakeholder. We have to bring in governments, we have to bring in the owners, and most importantly, what is very crucial to understand, difficult to manage, is anything to do with philanthropy. This is another important topic that we are talking about. What is it that is manifesting as we move top to the top senior management? The conventional method is top down, that is, whatever we call it is ego that builds the systems, that gives the instructions. But as we progress with advanced technologies, we go to consultation, collaboration, communication. So this is how we have to move to the next level up. Whatever we have been doing is fine. We are able to stabilize, argue, make accountable, transparency, every good idea that came into what we must be doing and what we ought to be doing is reasonably good. Social obligation, social response. There's nothing wrong about profitability. There's nothing wrong about anything called rules and regulations. Two levels we have done. The AI technology is pushing us towards social. The next one is social responsiveness, which involves a multi-stakeholder idea. So therefore, where is the complexity stemming from? From within the people's side, from within the human dimension, we are talking about organizational complexity stemming from problem context, solution deployment, data access, analysis methods, decision making. This is proving to be a very nice reference that I have included. I will send the PowerPoint presentations to Kamna as soon as I finish understanding and addressing complexity in problem solving. It is not that problems are many, it is just that complexity is increasing and we need to have methods. The people are clearly experiencing that, oh my goodness, all of a sudden the complexity of the problems is increasing. One more dimension comes into picture when we have people. Today, people are all into 5 generations. Simultaneously, a given organization is working with 5 generations of people, and therefore the ego as a thing has to vanish first because it doesn't make any sense. We will have to live with 5 generations. Traditionals, baby boomers, Generation X, Generation Y, Generation Z. So, therefore, these are the ways in which the people in any given organization will have to move further and address, take on that challenge head on, celebrate it. Complex operational decision making in networked systems of humans and machines. It's a multidisciplinary approach. In this context, you can fight for digital rights. You can fight online harms and content pollution. You can fight personal addiction and privacy risks. The fight is to shape it into safer, more open, and less intrusive tool. Technology should be like this. It should be safer, more open, and less intrusive tool. Algorithms are programmed to keep you glued to the screen by showing you content that triggers emotional, often outraged responses. It is a system designed to maximize engagement, not foster understanding. But what should people be doing? Understand. So, my way of looking at responsible AI as I went through the content and all is to first understand that responsible as an idea, as an ideology, is first people. Always people first. Then we will move to AI. House of Commons, Science and Technology Committee, UK House of Commons, Algorithms in Decision Making, fourth report of a session 2017 to 2019, shortly before the COVID broke out. Together with formal minutes relating to the report, I could gain some access to this. It was very useful for me to read, thanks to the internet. Algorithm is Commons, it's House of Commons. Algorithms have long been used to aid decision making, but in the last few years, the growth of big data and machine learning has driven an increase in algorithmic decision making in finance, legal sector, criminal justice system, education and healthcare, as well as recruitment decisions, giving loans or targeting adverts on social media, And there are plans for autonomous vehicle to be on public roads in UK. So many applications they have cited shortly before COVID broke. I'm not going to read through the second passage. It's understandable in a very nicely worded, simple idea called bringing in machine learning and artificial intelligence algorithms. The government has woken up to the fact that it is time to look at that social responsiveness, which is a multi-stakeholder idea. Up to social obligation, up to social responsibility, we have gone. Now we are pushing one level up. That's all is the first requirement. Although there is no single agreed definition of AI, there are similarities between many of those being used. AI is a set of statistical tools and algorithms that combine to form in part intelligent software. You versus the internet. Can you beat the manipulation game is the question. Take a stock on that. All people, individuals, in organizations, in government, society at large, how are we positioned on this? The nature of the algorithm is like that. Are programmed to keep you glued to the screen by showing you content that triggers emotional, often outraged responses. So what we can fight for is obvious. So this is all we can fight. You versus the internet. The fighting space is fighting for digital rights, anti-censorship, fighting online harms and content pollution, fighting personal addiction, privacy risks. The fight is to shape it into safer, more open and less intrusive tool. 5 steps to reduce organizational complexity in achieving these 3 levels, namely social obligation, good profitability, good living, social responsibility, and now social responsiveness by going hand in hand. UK House of Commons by far, according to my research, is the first to have acknowledged this social responsiveness idea. The first paragraph is something which points out to that. Very nicely written report. So, what is it that we want to do? It is people, but now people are not only citizens in a geopolitical context, but they're also netizens. They're global. They're global. So suddenly we keep remembering what Mahatma Gandhi has been telling as the simple living and high thinking. That has to happen. That will have to happen more and more. We are doing both. We are citizens in geopolitics, netizens globally. So we need to understand that responsible life as a netizen involves agreements, confidentiality, replying, sending, simply reply with haste to emails and messages that seek it. Reply with formality if appropriate. Be mindful of how a recipient would feel and react. Simple replies. Sending, think before you click. Once it is out of your hands, it's out of your hands. Confidentiality, agreements. So these are certain things which will now have to get into the repertoire of every individual who is connected to the net. That means everyone. All of us. We are all connected to this technology because technology is always wired. It's no more in isolation. Netizenship, netiquette. That's all is the essence of that slide. These will be there. The terminologies have to be there. 3 important things. Being a netizen. What is the meaning of netizenship and netiquette? These will definitely have to be in the repertoire of every individual, and that is what is making the people responsible. Now we are ready to move towards putting these 2 major ideas, responsible and artificial intelligence. To my left hand side, explainability, fairness, human design draw on the people. The right hand side, security, reliability and compliance are drawing more on the technology. This is how the responsible AI just gets well blended. That is the human and the machine. Right from day one, the problem was that how will the human interact with the machine? Now it is much more, it's a manifold idea. So please look into this explainability, fairness and human design on the human side. security, reliability, and compliance on the machine side, both of them coming together as responsible AI. Where are they? In the context of a social obligation, social responsibility, and social sensibility, and social responsiveness all together. They have to come together. That is what is the goal. In 1998, in an internet symposium, Andrew Shapiro wrote a nice paper, The Disappearance of Cyberspace and the Rise of Code. We will be governed by code. It was well anticipated. We will be governed by software. Everything will be defined by software. Imagine the emergence of a remarkable new communication technology. Using this tool, you can interact with anyone located anywhere in the world, provided they have same minimal hardware that you have. You can stay informed. All this is now a reality. The idea of cyberspace will disappear. All that we are doing is software definition. The Thinking Machine from NVIDIA. I am definitely thankful. It's a copyrighted material, but then at Anna University, we had some very good interactions with NVIDIA. Stephen Witt wrote a very nice machine, The Thinking Machine. NVIDIA and the world's most coveted microchip. That is what is the crux. Decision making under uncertainty is therefore the serious question that is bothering us. This thinking is what is it called? Decision making under uncertainty. Take a couple of minutes and find out how this imagery can be interpreted. What are the chances of reading this person, an image here? What are they trying to communicate? It's not modern art. But then that is the thinking that has to come now. Thinking in terms of intelligence, thinking in terms of many things has happened. Now, in responsible AI, all of us should be geared up to become what is called the netizens with good netiquette and be good citizens simultaneously, and therefore we need to have decision making under uncertainty. So what are we facing today? We should know that it is a fact of life, certainty, uncertainty spectrum. We are at some point in time close to certainty. Very soon we'll be far from certainty. At some point in time, we are very predictable. Please understand, close to the origins. That is the origin in this graph. It is close to certainty, close to predictability, but that's very limited. The space which we have to explore is so much. If we are simply here around the origin, we are not going to move, we are not going to make much. It is far from predictability and control. Towards this, far from certainty, far from predictability, lies the real solution that puts us all together and make us better stakeholders. Decision making, I just give me 1 minute. Decision making under uncertainty, theory and application, published in 2015 by MIT, is a part of a 4-book series, MIT Lincoln Laboratory series. The second one is very important, but what I am looking at is the third one. This is something which we will have ultra-wideband phased array antenna technology for sensing and communication systems. It's something which was a very nice book. And we will have to understand we are living in that world which is replete with not merely computing, but communications, sensors. A very big gamut of things are with us. Let me move to the next slide. The first part of this book, theory, a lot of models are there. You see how nicely articulated is the context. We need to make decision making under this much of uncertainty. And unless we move towards uncertainty and towards unpredictability and almost losing control, we are not really going to hit the solution. That is the challenge we are having. It's good to put these things together. Earlier on, it was different. We want to face that, we want to understand, but bring everything close to certainty, close to predictability. We were not getting solutions. We were not really getting solutions. We'll see later. So probabilistic models, representation, inference, parameter learning, all these you can read it up from the slides. But please understand that there is copious theory. Much like there was a fantastic theory for the computational model, which took us to that idea called intelligence, which was proven, verified, that it has clipped the world war by 2 years, saved so many lives. Over the past 100 plus years, we have been definitely indebted to this idea called computational model. There's no second opinion. Communications came, many things came. So there's fantastic theory built. We are not really on uncharted waters. These are all done several times. Sequential problems, model uncertainty, state uncertainty. There's a fantastic theoretical basis, particularly ever after Herbert Simon's work on decision making was becoming so important. Now you see what are the application areas. I like this book because these are the practical applications. My talk is also titled Responsible AI and its Applications. So we need to understand that the same theory that was governing computing computational models will also be amenable to these ideas of decision making. I referred to a paper, cited to a paper. Professor C.R. Muthukrishnan was also in my PhD supervisory committee. Probabilistic surveillance video search. Video search is happening, surveillance videos are happening. Everywhere we are happening. I myself was working on a problem like that. Somebody has announced an iPhone, lot of imagery is there. Can you predict who are the people who can really convert into purchases by observing them? Dynamic models for speech applications, optimized airborne collision avoidance, very important, very important. Multi-agent planning for persistent surveillance, integrating automation with humans. My approach was the cyber-physical system, that's secondary. All these problems are addressable, but what I'm trying to tell is we are not on a completely uncharted waters. We have a good computational theory, we have a good decision making theory, and these are all the practical applications which you and I are going through every minute, every second. It is probabilistic. They are all dynamic models. As one says, every model is wrong. Some models are useful. So we are not communicating much on these. They are all well under the hood. But it's very, very important to note that all these practical applications are having that complexity which wants the organization, the administration, the social commitments, the social responsibilities, and more openness, more safety stems from being more openness. All these things are pushing us towards that idea. And we want it to be regulated, controlled. We cannot simply lose everything on philanthropy. Even though that's a topmost requirement, right? There's no better word. I couldn't find a better word than what it is. CSR is doing well. I have immensely gained working through NASCOM and through the CSR provisions. We have been working on some models. Probabilistic surveillance video search, dynamic models for speech applications, optimized airborne collision, multi-agent planning for persistent surveillance. These are simple excerpts. It's a nice book, lot of maths, lot of theory. Please be rest assured that putting together responsible, the idea is a big idea called responsible, a big idea of AI is not on uncharted space. It's well articulated. However, the existing approaches are bordering on chaos. We are seeing everything happening like that. Couldn't resist putting this slide today, but then it's a fact of it, fact of life. It is bordering on chaos. Why? What is the reason? Take a look. A day in the wonderful world of data, the three references sourced. A day in data, petabytes, terabytes. Money is billions, exabytes. It's too much. One day in various devices. Just look at it on a wristwatch based approach. We are getting 28 petabytes of data. 65 billions of rupees are moving around data. It's something which is fascinating, which we should look up to. More computational power than ever. It's a classic case in the early 90s when India was embarking on the mission for supercomputer. The same question was asked, what are the applications for supercomputer? Why do we need supercomputer? We don't even know who will use a normal computer. But today, see the power of computational power, processing units, it's something which we should look into. Volume, velocity, veracity, variety, validity, value, both in terms of data value as well as the money. Now, this much is happening with data, and what is happening is the real world patterns always have inequality, discrimination. Discriminatory data will be definitely there. The real world is giving data, yes, but for what? We need to design for a use to go back to the world. Otherwise, we are always haunted by the real world patterns, inequality, discrimination, discriminatory data, application injustices, biased AI design and deployment practices. So, therefore, the real world is there, gives data. We have to have a design principles. We don't have that many right now. However, we know that we need to build that idea based on cooperation, collaboration, coordination, and the technology around it. So, from chaotic systems to what we are talking about is complexity science. We cannot escape that paper in 1998, written very nicely, way ahead in time. A very good visionary paper which we should look up always. That's very early written. My goodness, what happened to that? It was there all along by. Anyway, if I missed it, I missed it. Yes, it's here. The disappearance of cyberspace and the rise of code. We are governed by the code, governed by what has been written across all these application areas. But one single reason, the data explosion. It throws out data. You can read all this if you have good design rules. More computational power, phenomenal computational power. And in all these exercises, we need to have cooperation, collaboration, and coordination, which is people-centered. Our responsibilities as individuals, groups, organizations, in general, people, citizens, and netizens, is to build these ideas: cooperation, collaboration, and coordination. Responsible AI is thus bringing both into focus on big ideas. Then we move into complexity. Here, as I promised, what is the way out of chaos? Learning. So the second and third waves of AI, first one was perception. Second and third waves of AI are all centered around learning and deep learning. And we did generate new knowledge. That is the first positive. We need to talk about knowledge workers. We need to talk about how to scale that knowledge. India has been right in the forefront for so many thousands of years. We shared knowledge. Knowledge was always shared. It was free. Free the knowledge. That's how it was. And what is the basis for that? Learning. One of the finest ways of getting out of what is really moving towards chaos is learning. Second and third waves of AI have done that. Complexity is thus the watchword to go further. But let us not forget, any kind of a simple slippage will definitely take us to the chaos again. We can go back. It repeats that chaotic cycles are always there. Chaos is just round the corner, it's just the edge. Graph theory, scale freeness, small worldness, there's no big cyberspace. The world is small. The good network theory, dynamical systems, statistical physics, collective behavior, these are the hallmarks of an idea called complexity and a complexity science which we are looking at. And now you see what are all the applications of AI. Under the new perception, with good learning, AI can impact cartography, chaos theory, cognition, complexity, cosmology, design, again, virtually every field. So many applications are there. We can keep on working on it. Certain generic applications I have spoken about. Decision-making algorithms based on AI. This is the next important topic, a representative paper. I am not telling that's the best I have come across, but it's a very good paper. Sensors and Materials 2025, the last year, volume number 9, that's September 2025, 3-4 months back. Sensors and Materials. It is a very good paper, very, very informative. But then it is something which we need to really study further. Decision-making algorithms based on AI. AI does encounter a lot of bias. In my earlier presentations as well as listening to other speakers, we know where LLM can be hit or LLM can hit us. There are hallucinations. So many things can happen. Sampling bias, algorithmic bias, confirmation bias, measurement bias. There are so many types of biases which are always creeping into the exercise. What is the trouble here? AI systems amplify the bias. So this is the real danger in what we have been presenting earlier. It is to be noted that what we have been looking up for is world of data is full of biases. Let's not call them using this terminology. There are real world patterns, health, inequality, discrimination, discriminatory data, application injustices, biased AI design. People should be responsible enough to move to that new terminology: knowledge, complexity, complexity science, bias. There are such biases. And when we look at AI, it is having this bias component, it will amplify the biases. Image recognition system that use biased machine learning data sets will inadvertently magnify that bias. Researchers are examining ways to reduce the effects. Look at it, for example, cooking. An AI-based surveillance system can find all this. Agent, is it a woman or a man? Food, is it a pasta? Heat, is it stove? The way the tool is being used, place, kitchen. So you see, based on the surveillance data and looking at only those images that are reflecting cooking, you can look at this. It's a good algorithm to write, just get it out. It finds out whether it's a woman, what is the food being cooked, what is the heat source, what is the tool being used as a cooking tool, what is the place. So now you see it has 5 images sampled for the purpose of demonstration. It amplifies the biases. See the red one, a man is being recognized as a woman. What can we do? The algorithm is like that, the bias. The food is vegetables. Need not be. Need not be. Here it could not even recognize the food. Cooking, it could not even find out what is the heating source. So what's the point that I am making is, if you go back to this slide of probabilistic surveillance video search, it's probabilistic. Dynamic models for speech applications. Now speech is also looking at it. Day in and day out, we are working with data sets. I'm not commenting anything on the data sets. We are thankful that the data sets are available for some research purposes to illustrate these ideas. It will amplify the bias. So what do we do with that? We will have to somehow build people into governance, into a landscape called governance. Estimated global AI market, Indian AI market. There is a lot of talk about AI. We are not saying that it's all entirely castles in the air, but then it is important to note that what we attempted was a transformative AI built on learning, knowledge worker, deep learning, more exercises on that. We ended up at this point in time doing more of generativeness. The chat GPT, yes, in the last lecture also, Dr. Prakash was mentioning the same. It's the same idea. So weak RAI, it's a case of compliance for the business now. 3 parts are for the people, 3 parts are for the algorithm and businesses. The governance landscape of responsible AI is marked by fast evolving public and private regulatory approaches. The legislation is very weak. If I go back to that same report of the House of Commons from 2019 to now, more debates, more. That's how those institutions work. This is from the European Commission, Responsible AI and AI for All. It's a nice idea, very good idea that we have been talking about. But then it's the governance that we have to bring in to the people, and we need to understand those ideas. Global awareness around ethics is growing. Why is that so? Because there are always two components to a decision making. One is fact. Nobody can do undeniable facts. The administration at the organization level will emphasize on the facts. That's undeniable. The second part of it is ethics, which is subjective, which is individualistic, and that is what we need to look up in the governance model. Global awareness around ethics is growing along with initiatives by policymakers to boost AI in their territories and beyond. Globally, number of ethics principles by organization type is increasing. Government agency, intergovernmental organizational agency, private company, people are now responsive. People have understood the power of technology is so fascinating that we would like to put this on us. That's how all of us are doing these courses. If all of you are here, it indicates that responsiveness at all levels, individual, your department, and your institution. We need to build more. We need to take it to the next crucial step of the students. It's something that I picked from the Niti Aayog and ASCOM. Quick glance at responsible AI initiatives. Standards are getting developed. A few years back, I got into 3 standard groups for data related to data, which is what I thought would be the number one concern. That's how my lecture flows. This lecture is organized like that. The data we need to focus on. Microsoft Responsible AI Standard, private regulations. A lot of regulations are happening. Policy guidance, we need to still look up on the Alan Turing Institute, the Future Society. A lot of things are happening. Very good ideas are coming forth. But however, what we need to look at is the governance. That is where we need to. I won't know, I'm not hazarding anything, but what's the pace, what's the right speed is a big question mark. So we need to get inputs on this. The Responsible AI Hub at NASCOM, fostering responsible AI adaptation. Now, it is not likely that we will be adapting all the solutions around the world straight away. Continuing weak responsible AI compliance risks public trust and safety, precludes growth and scaling opportunities for startups and enterprises, could result in unfavorable forms of regulation hampering industrial innovation and growth. These are the concerns that we have to talk about. The way People are always nice. We want to build trust at all levels, the lowest level to the highest level. But then the nature of technology is that weak AI, which is what we are really going through now, we're not really strong enough. It's not fully transformational. There is a risk for public trust. There's a risk for public safety, precludes growth and scaling opportunities for startups and enterprises. By increasing the number of startups and enterprises, we have got some nice data points through NASSCOM themselves. It's a very good place. I visited their startup facility in NASSCOM. I went there in person. As a very early days, a nice facility was provided. Startups were given a support system, a supporting ecosystem to thrive. But then the data points are all necessary to understand very carefully. Could result in unfavorable forms of regulation, hampering industrial innovation and growth. The flip side of this weak AI is becoming too very obvious. What is the solution? We have to become stronger and stronger. We have to invest more and more into developing people alongside this technology. It's so fascinating a technology called AI. The governance landscape of responsible AI is marked by fast evolving public and private regulatory approaches. But then where is the government coming in? That's the same story which we need to understand of the commons, but it happens. In other countries, it's somehow it's a little more slower. There is a very good toolkit. I had spent some time with this NASSCOM Responsible AI Toolkit with the dedicated support from Responsible AI Working Group. NASSCOM produced a set of actionable tools and guidance to enable businesses to leverage AI to grow and scale with confidence, prioritizing user trust and safety. So the augmentation for weak AI is a toolkit. Augmentation for weak AI is let's put more force, more pressure on increasing the pace of adapting and adoption, but still it is not strong AI. The most viable and the most desirable solution for the present weak AI adoption condition is to strengthen ourselves on that same technology. We have to face the technology. We don't have a choice. We need to build further and further. It's not merely new terminology or new buzzwords. It is something which we need to become stronger on. Governance framework recommending management tools and structures for enterprises to assess and mitigate ethical risks arising from deployment of AI solution. There is no second opinion. In ethics, there is usually no right or wrong answer. It's a personal best answer. Ethics can be individualistic. Ethics can be subjective, but it has to blend with the facts. That's the real challenge. That's the real challenge which we are talking about. And we want it to happen in a very strong governance framework, recommending management tools and structures for enterprises to assess and mitigate ethical risks arising from the deployment of AI solutions. Architect's Guide prescribing responsible AI best practices. These are certain ideas which are coming together. Again, a very nice attempt of bolstering, supporting, propping the current stage of weak AI in which we are in. But there's still a long way to go. Let's recap all that we have been talking about. Let's understand those terminologies. Two very big ideas, responsible and AI. How do they come together? The notion of responsible is bound to duty, bound to obligation, individual, group, roles, tasks, and duties. That's the response. Within the ambit of the duty, which comes along with the role, and certain responsibilities which are bordering or highlighting ethical and moral behavior, as it requires individuals to take ownership of their actions and acknowledge the impact they have on themselves. We need to empower them at all levels, individuals, groups, and the organization. It's absolutely essential. I'm just doing a quick recap of what exactly we have been talking about so that we'll have a single page on progressing further. Next few steps. Accountability, recognizing and accepting the consequences of one's actions. We need to build people to that grade. Trustworthy in fulfilling commitments. It is not that, somebody can take a decision, therefore we should be careful. No, these are the props because they are all in transparent mode. Accountability, recognizing and accepting the consequences of one's actions. Reliability, trustworthy in fulfilling commitments, obligations, and meeting expectations. Ethical decision making, avoiding actions that harm others or violate societal norms. Learning from mistakes, using them as opportunities for growth and improvement. Responsibility plays a significant role in building trust and respect in relationships and contributes to a sense of integrity and dignity in individuals and communities. We don't have an opportunity to fight anymore. We can only talk rights and get them. Why do we want to fight for our rights? If all these can come together, both a happy blend of a human side, which is not necessarily all factual, not necessarily all objective. We can have individual, we can have subjectivity, we can have factual. If all of them do come together, where is the question of fight? We'll simply say it's a right and go ahead. A vision that was always been the cornerstone of any democracy. How are AI risks and challenges generated? AI is shifting from human expert knowledge to machine learning. As I mentioned, learning is what that has allowed us to break away from that edge of chaos in a nice, easy, measurable, and tangible manner to produce knowledge workers. But then there is an error in this. Initial weak AI models were problem driven using strong statistical experimental designs. Many current AI models claim without proper validation to be strong AI. Validation is one word which we should be careful, and I'll come back to it towards the end of my presentation. We'll have to discuss further on that. Many current AI models claim there is not much of validation to be strong AI. That's identical with human intelligence, either by its organization or its results. Again, please understand that the notion of intelligence has been strongly rooted in the ideas of computing, computational models. We have a way of working with it. Now it is no more a serious matter of debate. It is there. A lot of people have understood over the last century or so, and we have also taken up the benefits of that. Thinking, intelligence, they were all there. Now we have to add a new dimensionality to this. Instead of simply calling intelligence plus something or intelligent decision making, it is just intelligence decision making. And what is the core component in this? Learning. Two waves of AI have addressed this learning, and we have succeeded very well. Misrepresentation, misunderstanding of artificial narrow intelligence and artificial general intelligence. Why general artificial will not be realized? Humanities and social sciences communication. The very good paper published in Nature in the section Humanities and Social Sciences Communication. So when I'll go back to that slide. We'll go and do a quick recap of how we are looking at. So you please look at this error on test data, error on training data. What is ChatGPT? Pre-trained. That data is fraught with bias. That data is fraught with that 6 V's of huge data, unstructured, variety. There is an error on training data, but then it is pre-trained. Error on test data. Have we tested adequately? The answer is no. How much power is required to generate first? We are seeing that massive computational power which is not centered around a supercomputer. We are not doing it. It's all there. A massively parallel idea is happening in a Ziffy. And some of my students till recently were indicating that about $10 or so, they get phenomenal computing power. I myself had a remote access through open powers to a good cluster of computers, very, very powerful computers in Oregon State University. So there is error on training data. There is error on test data. The predictive errors are compounding. And we won't know because we don't have a way of doing that exercise. In the last lecture, I have mentioned the millions of rows in an Excel sheet can be generated, becomes fascinating, but how do we know very quickly whether it is really tangible or the gap between the real world? This time I'm doing a bit of back and forth, I couldn't avoid it. Is very, very obvious. The real world data is not the data which we are getting to process. It is easily recognizable, and then we look into it. We have to build it into the real world. That is a challenge. So we have toolkits, we have some strong definitions. Why general artificial intelligence will not be realized? It's a good nature.com article. My apologies, I should have given more bibliographic details, which I will send it. So there is an error on training data, there's an error on test data, there's an error on human, mistakes happen, organizational mistakes are happening, software is like that. There is nothing called cyberspace. We are there, we are simultaneously citizens based on geopolitics and also netizens. Simultaneously. We are both. We are both global and also bounded. Therefore, what are the questions that we are facing? Old questions, but more stiffer now. Because the frantic pace at which we are all expected to be responsible as humans, and technology which is in alignment with responsible. How do we do that? Verification addresses whether are you building a software right, ensures that software system meets all requirements. It takes place first including checking for documentation code done by developers. So what we are really living in, working in, regulated by and controlled by is a code space, not that cyberspace that was there in our thoughts. It has static activities like collecting, reviews, walkthroughs, verification on a weak wicket. For the last 70 years plus, verification and validation remains one of the biggest challenges, very daunting challenge. And are we really compounding these challenges is a bigger question. We are not able to convince ourselves through verification and validation models in many of the outcomes. How many times can we look at those pictures collected as 5 sets? How many of us can do this? It throws out so many in a Ziffy, voluminous data set for surveillance. Everything will come. How many of us are willing to sit down and collate saying that if you put together, we will understand what is the concern? But then it is so nice to note that the data is so fantastic. It will tell the agent that is a woman or a man. Agent is a nice term. In the last lecture also, Dr. Prakash was talking about agentic AI. Food, what is the food being prepared? Just from that imagery. Heat, stove, tool, what is the tool which is used to get the cooking done? So you see, there are so many things. There are errors. One error is something like that. How many times can each individual collate all these data, sit down and find out? This possibility exists in a handful of images that you have processed. Therefore, verification is becoming stiffer. And hence, please understand, if you walk through my lecture towards the earlier slides, if you please consider walking through the lecture, walking through the slides, the earlier slides, we should go back and say that, thank God, there is a well-established computing theory, there's a well-established method of computation, computational models. There are fantastic theories behind decision making, which are allowing us to attempt those complexities which we have been talking about when we are putting together responsible and AI. Validation addresses whether are you building the right software, ensures that the functionalities meet the intended behavior. It occurs after verification involves checking of the overall products. It's done by testers, not developers. And how many test cases? Please see how the earlier lectures were talking. Can you generate sufficient number of test cases to convince yourself to go ahead with whatever was the output? Very difficult questions. It remains one of the toughest challenges in the way we progressed building software, but that's the best bet as of now. So it's pre-training, transformer, fine-tuning, and reward model. We are at best doing fine-tuning. We are not yet doing a formal verification and validation. We are doing some fine-tuning, a reward model, which is very modest, weak AI, and therefore we think that we are having safety. We can always think of those nice ideas of Internet Safety Day. It's always there. We are in the safe hands as of now because of the progress which we made, built with very nice visionary ideas, and then we are progressing. In a computerized system, imagine that it is like this. There is a computerized system, there is software, there is hardware. Between the software and hardware is GPT. It's just an imaginary idea, an imaginary model. The GPT is there. Now, are there ways and means of checking whether we are doing the thing at least in an acceptable manner? The answer is drawn from an earlier experience we had. In 80s, there was this idea called virtual machine. A virtual machine is something that is picked up from a bit of a hardware, a bit of an interface, ABI to the hardware application binary interface, a bit of API, application programming interface. That coming together of APIs, ABI, and a hardware abstraction layer gave us a fantastic theory, gave us a fantastic application called cloud computing. Today, most of the things are happening only in the cloud. We don't have to invest on machinery. We don't have to invest on the memory. We don't have to invest much. Everything is service-based. Pay for the service. Platform as a service. Software as a service. Anything is a service. The service-oriented architectures have been found working well. It is a commercial idea. It's commercializable. Again, nothing wrong about talking profitability. It is there. It's a good idea. We should be there. We should be talking about it. There's nothing wrong about it. So what we need to look at is to see if that model can be adapted like this. Instead of that virtual machine, what happens if we include it as GPT? And if this model can be verified and validated, there's nothing like it. Something like this, we should be able to think. Computerized systems, software, and it is not so difficult, I would think. So this is where the core discussions are being presented, but then what we should understand is just go back. As I said, I am planning to go a bit of back and forth. How do we deal with this many biases? What is the way out? If there is anybody who is willing to answer, share an experience, they are most welcome to share in the chat. But then let me see how we will move into the chat mode. Yes, there is a chat here. Is it a question? No, it's just greetings. Anyway, let's see. Let's see how we can handle. Any ideas? I'm putting that slide again. You're most welcome to participate in this. Automation bias. What is that all about? We won't know what is getting automated. We have to have a way of thinking that it is as per what we have planned, what it is as per what we have wanted to do. But how do we do that? How do we do that exercise? Is a very big question mark. Even today, the concern is centered around not taking cognizance of the fact that there is bias. All the things which we have been speaking about are correct. But how do we verify and validate? And for that, and for verification and validation, we need to keep looking at the historicity, the societal consequences, the validation algorithms, challenges. Can we think of having that virtual machine model? Somewhere it is working, but then there are training dataset errors, there are trial and error errors, they keep on happening. System modeling, good models are existing for everything. Proprietary specifications, falsification through optimization, the shortcut methods, shortest path, is it the best? Falsification through planning. There are so many certain things. Failure distributed. The failure is also getting distributed. That's something which we should be very careful about. Failure probability, the cost of failure. It's something which we need to be clear about. And we should know that how much ever we try to make fail-safe systems, several failures simply go unescaped, simply go unnoticed. It's so minor, we need not know. Reachability for linear systems, reachability for nonlinear systems, all these things are matters of concern. Explainable AI was around for quite some time, and the runtime monitoring is becoming very, very difficult. The dynamical system is so fast. Everything is so fast. In a Ziffy, in 1 minute, petabytes, yottabytes of data are being created, used, consumed. Unbelievable types of data. They get converted in one form to another form. So, what we need to understand is, therefore, bank more on those firm basis. Please look at the toolkit which NASSCOM developed to become responsible in terms of using AI. It's a very good idea. We have to look at a maturity assessment tool, not merely capability. How mature are we in looking at all these things? Enabling enterprises to independently assess and monitor the development and deployment of AI solutions. We are drawing this lesson primarily from those days of software development, software quality. Quality is one word that should be the overarching idea again in all these things. So we should have some methodology of having a maturity assessment. Capability, we are all good people. As people, we don't have any concern. We are doubling up. All of you are attending these courses, learning with a clear intention that through the education institution where you belong to, you will take it to the students. And they will be the investment for tomorrow. We cannot look into it now, but it's a fact of life. Maturity assessment tool, capability, maturity assessment tool. We should have a way of looking at it. It's a nice point that was brought out. But then what we need to understand is it needs a training by itself. Somewhere I was looking up for these topics, capability, maturity in this idea from toolkit. I hope it will happen. Governance is the next idea. First idea is maturity. Second is governance. It's just prepared like that. Third one is architect. We have to architect solutions. AI best practices. So those are the three ideas: maturity, governance, and architect. Nothing is difficult. It is not the case of difficulty, but we should be realistic in saying that after all that toolkit usage, we are still on weak AI. We are still searching for standards. They are still happening. Regulations are still yet to happen. We are yet to catch up with. And we are also having some good policy makers, policy guidelines, particularly the Alan Turing Institute has been putting up some very good policy frameworks for us to operate. Then the next important point after the bias and all, mind-boggling types of applications around what we have been doing. Presupposing that we will put together responsible and AI, the applications are so many, and we are really looking at this many serious tasks which are happening day in and day out. Surveillance, speech applications, airborne collision avoidance, multi-agent planning for persistent surveillance, integrating automation with humans. But then when we are putting together, this is the automation bias, which humans have a bias. Automation also has bias. When we put them together, we are compounding. We are compounding the exercise. There is no a square plus b square is equal to c square formula when it comes to responsible, because a part of it is subjective. Part of the decision making is subjective, and we can't escape on that. So when we are putting them together, how are they multiplying? Is there a regulation? From the standpoint of the theory, from the standpoint of the mathematics, yes, we are able to control. But what is the concern here? As the humans come more and more in numbers towards unpredictable, uncontrollable, and uncertain, we are having a near chaotic situation. And it happened faster. Computing, internet, and now AI, the number of people who have come in is so many, and it happened so fast that all of us will have to request NASSCOM and AICTE to have this course running in parallel. Every day we'll have 3 to 4 offerings of the course of these topics. That's how we'll have to multiply. How do we educate so many people and make them aware? So what we are putting together is the basis for computing, which gave us that great idea called a computational model, a computer architecture, the ideas of thinking, the ideas of intelligence, all in the machine level. And put together what we learned from the people level, namely the decision making under uncertainty. How do we blend them together? There are so many challenges which I have spoken. A mind-boggling way of putting these ideas together is responsible AI. Presently, it's weak AI. Presently, we are augmenting all this using some toolkits, searching for some rapid development of standards, rapid regulatory development and policies nailed down, the top-down approach, but we are still looking up for a situation where we have a golden mean in this exercise. That is putting together social obligation, social responsibility, social responsiveness. When all three come, we are still addressing those major responsibilities of profitability, corporate, and for lack of better word, I was using philanthropy as social responsiveness currently. They can look into philanthropy. That's all is my submission for the day. Any questions? Out of the chat mode. We have a few more minutes. So we are not entirely looking at an uncharted condition when we are putting these big ideas called responsible and AI. Intrinsically, we have been doing well. Our common goal before all this complexity and everything happened was very obvious. We don't want to blame technology and we want to build trust. There are a few blanks that are there, but we want to build trust at all levels. That's the goal. Trust is the key. And we cannot forget at any point in time that responsibility is often considered synonymous with decision making. The one who decides pays. Principles are very clear, very obvious, and what we need to understand is from Herbert Simon's work involve factual and a value element, which is ethical and subjective. Thank you very much. Is Kamna in? Any questions? Yes, I am seeing a good question. Can we say that corporate responsibilities are opposite to decision making? Decision making at what level? At a corporate level, they are justifiable. Is it in favor of a given individual or a given society? Is a moot point. Therefore, we implore once again the fact that it has to be a good blend. The goals should have a redefinition. We should be responsible and the technology. The goals of coming together of multiple stakeholders may require a redefinition. It is something which we should be careful about. That's a good question. Any other comments on this? The question is good. Raja Mahanti Surya Kiran. Did I get the name right? Okay. Very good. At the middle level, that's nice point. That's a good question. That's a good reminder. Well, let me just take you back to that slide. What he's asking is at the level of corporate responsibility. Here, it's the top management. Is it opposite of decision making? No, definitely not. Why? Why is that so? Here it is corporate responsibility on the left, which goes from bottom to the top. What is coming down is from government regulation to top management. So where is that concern coming? The levels of corporate decision making are flowing down. Responsibilities are moving up. That's the effect of complexity, which I have used in this slide, which we should look into. The impact of complexity is here. We need to look into that slide very clearly, and then we will understand the reason why they flow upward. Decision-making authority must be distributed downwards. Empowerment. It should go downwards. Whereas authority should flow downwards, responsibility should travel upwards. Therefore, we are often ending up with this situation. It cannot be factually established, but within the ambit of the top management and the corporate responsibility, the answer is it is arrivable through what Herbert Simon has given us as a framework. Factually, it may not be establishable. I can't answer that question in a binary, yes or no, because part of it is factual, part of it is subjective and ethical. As simple as that. So you'll have to build it based on scenarios. We have to build it based on what is it called? The administration should focus on objective factual analysis. That's a nice shift. Something called an administration should happen. It's not middle or whatever it is. A concept called administration should run through everything, both bottom up and top down, and with a focus on factual. Build people, make them happen. Responsible as an idea will have to start with people first, and then the technology will come. It's not a binary answer. You'll have to look into that aspect. It is a blend of both factual, verifiable information and a value element which is ethical. Both of them should have to come together. More responsibilities, less decision makers. Well, it will become a pleasure because technology is given by them. The decision makers have taken a decision on what technology will happen. Good comment. It's a pleasure. Owning up responsibilities will be a pleasure. Technology is there. It's up to you and you are empowered. How the bounded rationality and these stages connected in real organization decision. Bounded responsibility simply means that we are having limited information, we are having limited time, and we are having limited cognitive capacity. We need not understand each and everything. We need to have trust enough. There will be what are called, unknowns, simple unknowns. We have to learn to live with unknowns. Everything need not be known, everything need not be established. This is a fallacy in data gathering. One question leads to another question. If I say that I am here in XYZ place, why are you there? What was the need for you to be there at this time? When are you going to leave the place? 3 questions come automatically. All appear to be relevant. So we need to have that empowerment to filter out. Discretion is something which we need to build. All right, you are at that place. It is of no serious consequence for me. I won't bother about it. Or as a matter of fact, there's nothing called cyberspace. It doesn't matter to me where you are. Right now, what is happening? Dr. Rajkumar has asked a nice question, but I don't need to know much about him. It's very nice that we have a policy guideline coming from the NASCOM that the name should be given. For recording purposes, that's a good policy. Beyond that, what? I need not know anything. Absolutely nothing much is necessary for me. Even if the question has come straight away, it would have been fine. Can you give a real educational example mapping intelligence, decision, and choice? Your choice based curriculum system, CBCS. There are so many choices.
Yes, yes, yes. In fact, we are almost on time, Dr. Rajkumar, and but Dr. Gopal has still answered your question, so thank you, Dr. Gopal, for that. We are almost on the dot. In fact, up the time is almost over. But Dr. Rajkumar, we can be in touch. We have you can be in touch with Dr. Gopal on his LinkedIn, and any questions, please feel free to reach out to me. In fact, I also want to take this opportunity to thank all of you for having such a long day and still choosing to upskill, and to Dr. Gopal for taking out the time to share his wisdom and his insights with each one of you. We would be very happy to extend the course to your students as well. We have a lot of offerings for students also, like internships, project based learnings, tools by various tech giants, and lot of industry exposure can be provided to students if they are a part of NASCOM, SSC NASCOM, and they get into a partnership with the Sector Skills Council NASCOM. So do reach out to me if you would like to extend all the facilities to your students. And tomorrow we will have the session early. We will be starting at 2 o'clock. So Ranuji, tomorrow the thing will start at 2. I've shared the schedule in WhatsApp group, so please see it over there. And I'll see you all tomorrow at 2 o'clock. Thank you so much. Thank you. Thank you, sir.
Thank you very much. And any feedback will be very useful for me to improve on it. Thank you.
Yes, and Gopal sir, I'll be in touch with you. If there's
Sure,
anything, any
we will.
movement from Mahindra University, please do let me know.
Sure,
Thank
we'll
you.
do that. We'll do that. I'm also thankful to NASCOM over the last several years. Well, it's definitely 15 years. We have been working together, and I learned a lot from those professionals. Thank you very much.
Thank you. And sir, if a meeting is needed with the Mahindra University, then
Yes,
I'll be happy to come and meet them also. So do let
most
me know.
certainly. Most certainly.
Thank you. Thank you
Will
so
be.
much.
But give me time.
Sure, sir. Sure.
Thank
Okay.
you. Thank you. I'm stopping the sharing first.
Yes, yes. And Dr.
And
Gopal, for the next week schedule also, I hope that I can pencil you in.
yes, please.
Okay. Same time, we'll do your schedule like same days. We'll just
Okay,
repeat it. Okay. Thank you so
very
much.
good. Thank you.
Thank
Thanks
you.
a lot. Very kind of you. Thank you. Bye
Thank
bye.
you.
Good night.